We've got about 25 minutes or so, 20 minutes to have a discussion and pick up where we left off. So before we get into questions, what I would like to do is just to introduce Francesco Carobolante. He is Brian's partner in crime on the IEEE working group. Francesco, you're the principal of IOTissimo. I hope I pronounced that correctly. What I thought I'd do is just kick off with you and kind of give us your impressions of what you heard through the various talks, and feel free to add a couple of comments in terms of your specific personal experience, which I know has covered many different aspects of energy.
Thank you. Thank you. And I believe that this previous session actually was a great introduction to the issues of energy efficiency, since it covered a lot of different aspects of it. And maybe I can touch on a few that were raised that I think were very significant. First of all, being green may also lead to bringing in more green, in the sense that being green is not against actually profitability. Actually, this reminds me of one of the reasons why I got into this energy efficiency is at the first 5G World Forum, there was the first speaker or the second speaker of the whole event was talking about real-time, self-driving, all those kind of things. And at the end of the talk, I asked him, have you considered in a city environment how much computing power you will need to actually do that? And this executive said, well, that's an interesting topic for the university to study. And I'm like, you don't get it. This is not an academic issue. It's a financial issue. So again, contrary, for example, to the IT world, where fundamentally they hit the wall of energy much sooner, and therefore they had to address the efficiency. In the telecom world, basically, that hasn't really happened until now. And 5G is really the first time that they hit the wall on the energy all over the place. And so again, when the scope of human actions reach a dimension that affect the local or global availability of resources, and energy is a resource, that's when we first come to the conclusion, oh my God, we need to do something about it. But we could see it coming many years ago. So it's not like we couldn't forecast that. But of course, until you hit the wall, you never do anything. So now it's time to catch up. Another interesting point that I heard actually from my colleague Colleen was about regulations. Yes, regulations matter. And in fact, oftentimes they encourage the wrong behavior. And so we should actually encourage regulations because obviously they need to be careful, not like the ones in Santa Cruz, right? Okay, but the same is true for the water in the Central Valley of California. Fundamentally, free water means that nobody cared. So again, we need to embrace some regulations that are aimed at pointing us in the right direction. One thing that we need to also remember is that while 5G has brought all kinds of new capabilities to the network and the use cases, it has not reduced the cost per bit, let's say, of the transmission. So fundamentally, we need to understand how to better sustain the business cases due to this increased capabilities, because the increase in volume is not going to come from the fact that we have a lower cost per bit. So I think that Brian made a great explanation of what how the energy impacts not only the CapEx, which, by the way, increases exponentially with energy. You know, you don't need anything in a chip. Okay, that's fine. You put a chip and it burns a watt and you don't care. You start putting 10 watts, you need a heat sink. You start putting hundreds of watts, you need a fan, and you put kilowatts, you need sometimes water cooling and so on and so forth. And of course, the rubber meets the road when you try to deploy this, and you find out that in the cities you may not be able to put a fan on your cell. And then California comes along and said, for safety, we may introduce regulation that impose 72 hours backup power to the cell. And you're like, oh shit, okay. Now, what's the cost of deployment? Leasing the place, maintaining all this, and all, not just the equipment, but the whole thing that goes with it. And so these are the really key issue. And so that's why, as I said, being green sometimes, thinking efficiency first, is actually important to actually get a good financial return later. Some of the problems I think that have been exposed here is the siloed approach of the industry, where basically the guy that makes the power amplifier says, hey, I shaved 2%, and then doesn't realize that maybe the modulation scheme has screwed up completely what his design was. We have examples of this siloed kind of situation. One is in fact the modulation scheme, as was mentioned. You basically increase 2% the channel capacity, and you burn twice as much power. I mean, that doesn't make any sense. And same, for example, now with Massive MIMO, where we have somebody that wants a complete digital RF channel for every element of the antenna. I'm like, now we need a supercomputer to run an antenna. I mean, obviously, these things don't make any sense. And there are companies out there that have found different solutions. So I encourage you to look for it. So again, I think these are the key things that we need to resolve. And there's maybe, I'll just mention 3 things that are somewhat important among the many. We need to be careful at the fact that it takes more energy to move bits than to compute bits. Okay, this is something that you go to any semiconductor, AMD or whatever, they'll tell you that even moving by millimeters takes more energy than computing. Okay, and obviously if you move by kilometers, it's even more. So for example, I'm very excited with regard to movements like TinyML or things like that, where fundamentally we're starting to think, how can we efficiently do computations where the data is so that we can reduce the amount of data that transits. The other thing that I heard, wasted energy is an opportunity. So obviously that goes into energy harvesting and trying to use the energy that is wasted otherwise. And it makes me cringe when I hear, by the way, I'm actually historically, I've been doing a lot of developments also in wireless power transfer. And I cringe when I hear somebody that wants to power industrial IoT with microwaves. I mean, I'm like, you gotta be kidding me. So, the efficiency is about 0.1%. Okay. If we have 1 trillion devices with that efficiency, you need so many power plants, you can't believe it. But anyway, it's nice marketing, but that's okay. So we need to think in terms of, okay, how can you scale something? You cannot scale anything that is not efficient. That's the bottom line. And the last thing is there's a symbiotic relationship between information and energy. Information is also energy, but we should always think about how to symbiotically combine them. And that's true not just at the edge, where we need sometimes to move both energy and data at the same time. And there was actually, at the last IMS, actually a group of people talking about this. But also, for example, at the grid level, where we are talking about helping somebody else reduce their power consumption. Okay, the communication networks have a lot of information that are very useful to the grid to optimize the grid and vice versa. So again, there's a lot of opportunities to actually create value by just working together. So just a few points.
Cool. Thanks, Francesco. So let me kind of follow up on the promise and say, any questions from the audience that came up during the talks? see you fiendishly making notes. Yeah, I think following on, if you could use the microphones, that would be great. Thank you.
Hi, my name is Kamal Sahota from Qualcomm. This question for Brian. When you were talking about, well, you had the very long presentation. No, you were mentioning that the devices on the edge could consume more power. Were you referring to like the cell phone batteries and things, or what was the, or is it charging of those? Or do they get
Yeah,
more?
maybe
I think
Francesco
yeah,
can
I
take
can
that.
quickly go with that. I mean, the point is that fundamentally there's two kinds of. So he's talking about the total need for generating energy relative to what is consumed, and the farther away you are from where the energy is generated, the more there's a cost factor.
Right,
that
because all of the
impacts-
losses, right? That go
Yeah,
with it, right?
and the ultimate thing is when you want to actually power a sensor with microwave. So beside the fact that you have to go all the way from the energy generation station all the way to where that device is, you're going to also have another 2 or 3 orders of magnitude in efficiency in transferring the power. So again, we have to look at all the chain, where the energy is generated, where it's consumed, and what's the ratio.
Yeah, I was just also saying, like, if 8 billion people had cell phones or multiple devices, how much of the energy of the total would that consume? Is that?
Yeah, so I think everything in terms of context for today that I saw, and I'll let Colleen, because she was probably talking a little bit to this, but did not really handle any of the UE type equipments, Kamal. So we were thinking of it more from an infrastructure standpoint, so an ICT view. Now, I think if you added in all of the $8 billion $8 billion handsets, maybe they are $8 billion, I don't know, it's probably more than that. But I think then you have to, that's counted in a different bucket within the overall energy usage.
And
So that would add some more.
also the Department of Energy has already regulated, for example, the efficiency of the chargers for the phones and things like that. So that issue became obvious a long time ago, and so there's already, quite a bit of effort, let's say.
Me?
Yes.
Okay, thanks. So to frame my question, sometimes energy efficiency requires behavior change on the part of the humans, not just view it as a technical problem. So with that in mind, are you able to quantify, for example, how things like shifting from broadcast, we all used to sit in front of the TV and watch the evening news, and now everybody wants to stream it. There are 5 independent people streaming, and all you've done is offset, right? So that convenience of being able to start and stop whenever you want, and what does that do to energy efficiency? Should we be, going back to broadcast media in some ways instead of what we're doing with streaming?
Yeah, Colleen, take that one.
Yes, I mean, behavior is a really big part of it. I think it's about what to prioritize. If, for example, we had Netflix, the whole stack, running on renewable energy and everybody's devices were recyclable and it was nice and circular, it doesn't really matter. If we are unwilling to take the time and energy to implement these circular economies and don't think that we can get to 100% renewable energy, then at that point, maybe we need to talk about technology change. It's a matter of prioritizing what we think is important in life and figuring out how to do it sustainably. If it's really important to us as consumers to be able to start and stop things when we want them to, it's up to the people making these technologies to help figure out how to do it sustainably. I think I also view kind of conference travel as part of this. We all know that it's inefficient to travel, but sometimes it's worth it just to be here face to face. It's way more sustainable to just sit there and be on Zoom. So in my mind, the challenge is like, okay, well, we know that people like traveling and seeing each other face to face. So how, what do we do as technologists and innovators and inventors to make getting from A to B as sustainable as possible?
So I can add something. So there have been some studies about broadcast, unicast. Of course, one thing is changing behavior. That is, go to broadcast TV or something like that, which clearly will not work, right? we are not going to go back to linear TV. That's out of the question. The question is that can there be some hybrid modes? So while we cannot completely change behavior of our consumption, can the producers of the content and the distributors of the content change their behavior and distribute content in a way that is semi-broadcast, broadcast at at some nodes, and then unicast at some other nodes, right? So there can be interesting explorations there. But I would also say that from a cell phone user's perspective, I think that maybe Francesco, you were also saying, and there has been some statistics. How much is the EV power consumption versus base station power consumption and so on. I don't know how accurate they are because but I believe that it's the base stations, it's the more machine operated things that need to be focused on more because see all of us, because of our battery, we are conscious about how much we are spending and so on. So.
Yeah, if I may add, certainly there's been a lot of work from these companies like Netflix, for example, to distribute content so that it's closer to the users. Buffering is a possibility. In the end, everything costs a little bit. And so I'm afraid that it's difficult to regulate those kind of things, and even behavior is difficult to regulate. In the end, it's going to be just cost. I mean, fundamentally, if they charge more because it costs more, maybe people will do it differently. But it's a very difficult challenge.
So, Francisco, here I would, like to respectfully disagree. And it's not on the energy efficiency I'm disagreeing, not on the cost I'm disagreeing, but on the mission for sustainability. That's where I'm disagreeing. If you look at any other sectors besides telecommunications, and I know that will be recorded, but I feel, this is my personal belief, having worked with operators all over the world, and I would categorize them in different ways, but the US operators to me have not taken the steps towards sustainability that European operators have, Asian operators have. If you go to various Asian countries, you'll see the operators are doing it not because of cost, but because it's their mission to the world, right?
It's a cultural issue.
Their commitment. So that needs to be done. That needs to be, I think, instituted here. There needs to be more activism in US about letting the operators of US do something because that's the right thing to do.
I 100% agree with you. I get worse performance from 5G here in the US than for 4G anywhere else in the world, and I pay twice as much.
Just want to add one thing, that the consumer behavior that makes a lot of sense to try and change, because it's not really a big sacrifice, is again, small habits like device recycling. Yeah. That one I would love, if we can come up with ways as an industry to help influence that particular consumer behavior, I think that would be a big win. Because it's not a major ask of somebody to get them to recycle a phone. Asking them to switch back from all the options in the world with Netflix back to just watching ABC, NBC, the big 5 broadcasters. That's a huge behavior change.
Yeah, certainly. Another question.
Yes, Elaine Tanaka with UCSD Ethnic Studies and Indian Health Service. So I first wanted to thank you for the forum and for your presentations. So my question is about healthcare. So I'm in healthcare, and I just want to see what your thoughts are about efficiency in the healthcare setting. Because as you know, our EHR, electronic health record, has to be on 24/7. We often have backup. We have to back up the data. And you probably know about the recent, it's not that recent, but we had a cybersecurity issue at one of the major health systems here where we had malware, and we were basically paralyzed for almost a month because we didn't have access to EHR. So just wanted to see what your thoughts were. Is it a hopeless thing to do for healthcare, or is it something that's even being looked at? So thank you.
So I've not personally looked at this. I've got maybe some personal thoughts on it, but anybody got a viewpoint on the healthcare challenge here?
You mean in terms of, I'm sorry, I'm a little lost here.
Personal.
You
I
mean
think it
in
was to
terms
do
of
with saving of records and privacy and backup and access.
in regards to sustainability and
Security issue. It's
no,
security,
so I mean,
basically.
I think it's a different topic, and I think that some of us do work in healthcare, and we are happy to talk to you maybe separately. But you don't have any question regarding sustainability per se, right?
No, whether or not sustainability is even
Definitely. I mean, if you look at the United Nations Charter of Sustainability, if you look at their goals, healthcare comes, center front as a way to achieve sustainability. But that sustainability is quite different, I guess, than the sustainability we are talking of here.
Yes, but healthcare is lagging when it comes to environmental sustainability. But I do know that, for example, nurses up at the UC Davis Hospital, they do have this in mind. Like, there's a lot of single-use equipment for sanitary reasons, and this is something that field is starting to think about. But I think they would also argue that human health comes first. So that's a really difficult challenge that these providers and researchers are grappling with. Is if health comes first, how can we how can we recycle these components that have contaminants on them, et cetera, et cetera. But people are thinking about it. That's all I know, is that there is some awareness of it and hopefully progress at some point.
So
Definitely the device manufacturers. In healthcare, medical devices is a big industry. And definitely there's a lot of work going on in sustainability towards that.
Yeah, that's a pretty deep topic. So to save I know there's another question here, and then we'll go to Peter. I don't know which of you were first. Peter.
Actually, I had two questions, but I'll ask one first.
Bit closer.
Sorry. I'm thinking from the consumer side, especially in the U.S. If you're a consumer who's interested in energy efficiency, it would actually be difficult for me to know whether I would choose Verizon or AT&T. Is there a thought that that type of information should be made publicly available or regulated? And I would honestly say, although there are regulations, I would say the same thing in my end user equipment. If I'm going to purchase a smartphone or a laptop, I don't see anything like you would have in a refrigerator, an Energy Star rating or something that actually allows me any information. So the first part of the question is, should that information be made available or forced to be made available? And second, do you think there's a willingness of the consumer to actually pay for it, right? So as a company that, obviously Global Foundries, we pride ourselves in technologies which allow higher energy efficiency. But the reality is, generally speaking, that allows us to win business, but not necessarily at a higher price point.
So I'm going to steal this one, because your point on kind of the industry, like reporting and regulation and lists of champions and lists of shame, that was actually something that was brought up in the Green G Working Group. And I think we say it in kinder words, but basically kind of initiatives to raise up the good players and maybe try to shame people who or companies that are the bad players. That was very much discussed and generally supported as an aspect of ways to change culture. Whether or not people care about it, adapt, use it, I can't predict that. And there's precedence, and organics have taken off in a huge way. So more information is always better, in my opinion.
Peter, I believe that in the ORAN discussions around ORAN Alliance, there are some conversations about having something like the Energy Star rating
Energy
tag
Star,
that goes on
or
your refrigerator.
Although I know it's very different, I hearken back to when the EPA there was a time when you wouldn't even know what the miles per gallon on your car was, right? That was, before the EPA came and put a label on it. There was no reason to even know, right? And it's kind of shocking in that regard. My second question is one where, honestly, I don't have very much expertise, and I hope the panel can contribute. But I know as you move more and more to software, the energy efficiency, especially around AI algorithms, seems to be something that's actually difficult to understand in some way. And if you were going to ask whether, when you do a search, whether Google or AWS has a more energy-efficient AI algorithm, it seems difficult for me to get that information. Is that something that people are looking at, or energy efficiency of software, especially around machine learning and AI, which is contributing to what we said. When we did the study with the SIA, the forecast of ICT is actually will exceed the energy consumption of the planet sometime around 2040. And it's mostly driven by the energy consumption of machine learning algorithms.
Yeah.
Yeah. So maybe I'll just add very quickly that that is a big question, because if you put machine learning to optimize the efficiency of RAN, and then you realize that the computing power consumes more power than the efficiency you gain. And that is exactly one of the reasons why, as Brian explained, we created black boxes that fundamentally you can put in anything, including AI, ML. So again, there is a way to account for that if we want to utilize a structured approach of systems. So we can address that. But the first thing is to make sure that we actually utilize a framework that allows you to understand if you're really making progress or if you're simply, talking about it.
Okay.
So I can say
So,
from my own personal
Sujit, I'm going to take this last question
Okay.
because we're tight on time and want to make sure that we cover this gentleman.
Hey, yeah, I'm Agrim from UCSD. So I had a question based on the microwave comment. So do you think there's a kind of a trade-off between let's say making the embodied carbon more efficient versus the operational carbon? Like for context, you can always put a battery at the tiny device and it's the most efficient thing. But then the battery is there and you are done. Like it's part of the embodied carbon footprint. You can avoid the battery, let's say, by having your devices powered up with microwaves, but then that's going to be bad on the operational side, as you have told. So what are your comments on this?
So I think this is definitely an energy harvesting comment. So I guess Colleen or Francesco, whichever.
We can both comment.
I think this is where something called life cycle assessment comes in, is the short and long answer, which is you look at the embodied carbon of using the battery versus the carbon it takes to harvest using RF, and calculate out which is better based off of how long you expect the device to be in use, et cetera, et cetera.
And then you, of course, consider, okay, what's the cost of replacing the battery and all those kind of things. So you need to really, understand the whole life cycle.
So then there's no clear answer, right? Like you can't be like cringy about people powering it with microwaves, correct?
No, I mean, there are situations where you need to do that, but it shouldn't be the first choice.
I see. Okay.
That's all. I mean, there's some cases in which you have no choice.
Yeah, I think his point was that wireless charging and wireless power supply has huge losses compared to just plugging it in. So if plugging it in is a viable option, if there's not a good reason to not do it, if you want to do it just because it's cool, that's not really the most sensible reason.
So just a minor comment. So basically, wherever possible, like if the tiny devices can be just wired, then that's the best thing, I guess. Like if you are thinking about it from the energy perspective.
Not always. You're not going to wire 1 trillion devices. That's why energy harvesting is probably the most reasonable way to do it.
But maybe
if
more
you
like
can.
the energy harvesting based on heat or already existing thing instead of powering it up.
Movement, heat, some other
Absolutely. Vibration, you name it.
Or using already present signals. There's some work from the University of Washington that harvests
Yeah.
radio waves from radio towers, TV.
I see. Okay. Thank you.
Thanks. Teo, I'm going to give you the last question
Thank you.
because I think then Kamal's going to rip me off the stage.
I'm
'cause we're-
Kuntio from Mitsubishi, one of those few companies that deal with fraction of watts to gigawatts. My question is this. First, a few comments. Our human brain is so fantastic. Right? We know that it takes a supercomputer today 14 minutes to process one thing, which our brain takes 1 second. The power that consumes our brain is so small. And the question is why? Our brain today, as far as we understood, and we have not understood our brain yet, according to neurologists, we only understand 1% of our brain. But nevertheless, to what we understand today, the way we process the information might be likely analog. So I'd like to pick your brain here is that as what you have commented, much of the energy is moving bits. And I can't agree more. In the IC, in the processor, a lot of energy goes into moving from memory back to processing and so on. But that is digital processing. If you're old enough, which many of them are not, you deal with analog computer. A differential equation you can solve in fraction of a second. You know how long it takes? Of course, nowadays, with the speed of processing, it takes very fast. But the power consumed is many, many times digital than analog.
I agree with you, and you know what the problem is? The laziness of engineers and Moore's law. But now that Moore's law is ending, hopefully we can start thinking again.
So what I'm saying here is that many of us are thinking along the line of digital processing. But it's maybe time to think about analog. Thank you.
Thanks, Teo. So with that, with an eye on the clock, I'm going to thank our panelists here for a great session. We didn't get into any of the considerations of the broader sustainability problem. We've had a couple of comments from Colleen, I think, along the way around the circular economy and how to think about that, how to think about the total energy involved, so embodied and so forth. A lot of other things that came up around how can we as engineers incentivize the right behaviors. And I think a lot of the things that we've talked about over the panel have really come down to one thing, which is laziness. Even charging your cell phone, I wonder why I'd want to do that wirelessly, right? I mean, it's kind of cool and I can just throw it on the side and do it, but plugging it in is probably a way more efficient use of energy. So I think as we think about that and we become more aware of our surroundings and the planet, really that was the intent of this whole session. So I thank you for the interest, and please continue the conversations in the breaks. And I know these guys will be happy to answer questions and continue the dialogue. So with that, thank you for the opportunity. And Kamal, I think you're on next.
Thank you, Mark.
Thank you.